Limits. Let f be the function defined on the interval from -infinity to a for some real number a. The limit notation, the limit as x approaches a from the left of f of x equals L, is called the left-handed limit. You notice a left-handed limit because of this little subtraction symbol as the superscript of the number a. And what that means is you're going to locate a on the number line, and you're only going to look at numbers to the left of a. You're going to be approaching a. You're going to get closer and closer to a. Here's an x value, and there's the ordered pair associated with it by the function. And as these x values get closer to a from the left, it's going to look like this. And you notice y starts going away first from L, but then it starts getting closer and closer to L. So as x is getting closer to a, or approaching a from the left-hand side, the function values are getting closer to L. And that's why the limit as x approaches a from the left of f of x would be L. So here's an example. Find the limit as x approaches 3 from the left of x squared minus 9 over x minus 3. Here's the number 3 on the number line. We're going to be approaching 3 from the left. So we're going to plug in numbers smaller than 3, getting progressively closer to 3. So let's look at the x values and the function values. So let's start really close to 3. Let's start with a number like 2.9. I'll plug it in, 2.9 squared minus 9. I'll divide that by 2.9 minus 3, and the result will be 5.9. Let's get another number even closer, because we're getting closer to 3. We're approaching 3. So a closer number would be 2.99. So let's plug 2.99 in. When you plug 2.99 into the function, you're going to get 5.99. Let's get even closer. Between 2.99 and 3 would be a number like 2.999. When you plug 2.999 in here, you get 5.999. So it seems as the closer we get to 3, the closer the y values or the function values are getting to 6. So I would say that the limit as x approaches 3 from the left of x squared minus 9 over x minus 3 is equal to 6. Let f be a function defined on the interval from a to infinity now. So now we're going from a up for some real number a. And then this limit notation is read, the limit of f of x as x approaches a from the right equals L, and is called the right-handed limit. This means that as x gets closer to a but remains greater than a, the corresponding values of f of x get closer to L. Here's x, and here's the f of x. Let's see what happens as x gets closer to a. It looks like f of x is getting closer and closer to L. In this case, we'd say that the limit as x approaches a from the right of f of x is L. Find the limit as x approaches 3 from the right of x squared minus 9 over x minus 3. So to do this, we're going to look at values of x and f of x as x is getting closer to 3 from the right. So x and f of x are going to go in these rows. First, I'll choose a number like 3.1. If I plug 3.1 in, I get 6.1 as the function value. A number closer to 3 than 3.1 is 3.01. 3.01 is closer to 3, so I plug it in. When I plug in 3.01, I get 6.01. So a number even closer to 3 would be 3.001. If I plug 3.001 into here, into the function, I will get 6.001. And it seems to me that as x gets closer to 3, the function values are getting closer once again to 6. So I would say that the limit as x approaches 3 from the right of x squared minus 9 over x minus 3 is equal to 6. This notation here is read, the limit of f of x as x approaches a equals L. Notice we're not distinguishing if we're approaching from the left or from the right. This means that as x gets closer to a from either side, the corresponding values of f of x get closer to L. Let's find this limit. Now you notice we did the left-sided limit of this, we did the right-sided limit of this, and now we're just doing the limit, and this is considering both sides. This limit only exists if the left-sided limit and the right-sided limit are finite and equal to each other. So remember, the left-sided limit we calculated, and we said it was getting closer to 6. The right-sided limit we calculated, we said it was getting closer to 6. So it seems as x approaches 3 from either side, the f of x, the function values, seem to be approaching 6. So we would say that the limit as x approaches 3 of x squared minus 9 over x minus 3 is 6.